and I'm going to be talking about a 3D printing process called laminated object manufacturing. Why did I select it? Building these um, microscale device, and this is a potential technology that could aid in one day building those out of additive, really help with bonding issues and things like that. So basically, LOM is a process combines additive and subtractive because although you're building still materials layer by layer, it's a lot of removal of the excess material, and actually you can't build any internal cavities because of that. So that's a real issue with this process. But again, the layers, the material are in forms of sheets, and they're bonded together by applying pressure, heat, and then there's an adhesive coating applied to the material sheets as well. And a CO2 laser is applied to trace that layer out, and then again the platform moves down, the roller moves across. As you can, so number one, you see the materials pulled across the platform. There's a roller, a heated roller that activates the adhesive on the material and it bonds it to the substrate or the layer below. The laser cuts the material into the whatever pattern of that single individual layer. There are cross hatches made in the material if that material is not actually part of that component to help remove it later. So a single layer is formed. The build platform is lowered. New material is again pulled across the platform, and the process continues until the part is complete. And so, as you can see, the different parts here of the actual system, there's a lot of waste generated actually. So, unlike most additive processes where you're able to selectively place the material, you're going to create waste. Some key process parameters include the adhesive layer, how strong that is, whether there's going to be any pockets or voids created between the layers itself, and also the thickness of the individual layers. So it doesn't make parts that are very precise or great finishes SLS or FDM or something like that, but it's going to be low cost. Again, this is not a very popular process, but it's used for mainly prototyping. Again, less detailed parts, and again, not a very popular technology, but there's a new company out of Ireland that I'll talk about later that's been using this technology to do some interesting things. So some of the advantages: low cost, no post-processing, no supporting structures. I guess that's what I meant by post-processing, but there is post-processing. You have to remove the excess material. No deformation phase change, so a lot of good capabilities in terms of keeping the material properties the same. And then again, potential to build larger parts. The current processes are limited by build volumes that are typically small. But then again, the disadvantages include material waste. Again, the surface definition is an issue. And again, the material is directionally dependent. And like I said, you can't create any internal cavities. Some of the materials used: thermoplastics. Paper is actually the most common, like printer paper you could pull out of your computer there. Composites. Now, ferrous materials, metals, non-ferrous metals, and ceramics are included. However, I found no supporting evidence of that anywhere. There's probably research ongoing about metal, and I think that would be an interesting case for our MBI center here, but I did not find any support for that. So looking at a case study here, uh, this is a model of a partial human skull, geometric toy, and then that's Voldemort. And so it's mainly used for art, like I said, create prototypes. One of the coolest things, though, as you can see, is you get a high definition of color, very vibrant color you're not usually able to get from other types of 3D printing. Again, it's made through normal paper. You take out your printer. This is from a company named MCore from Ireland. Low cost, relatively fast, and again, post-processing flexibility. So a good process if you're really just into prototyping and art right now. So looking at vendor one, this is Cubic Technologies. First to commercialize this technology in '91 as Helicis Incorporated. Changed its name in 2000. Went through some internal changes. This actually printer itself is a desktop printer, but it's manufactured by somebody else. But it sits on your table. However, it costs $15,000. So that's a very cost prohibitive printer. And however, this in this case they're using engineered plastic. Second vendor I talked about, MCore Technologies. They're based in Ireland. They took this technology and they applied their own innovative twist on it to helpfully lower the cost of the actual printer. And they've created another type of technology called SDL, selective deposition lamination. So like I said, the adhesive is applied to the entire material layer, but in this case, it would just be selectively applied. So you could probably have a better control on the shape geometry. So this is some of the printers available from them. The Matrix 300, which can make images like or parts like that, and the Iris, which actually I think is really cool. These are some of the parts they've made, and the one second from the left, that's actually a topographic map. So imagine looking at a book and having something like that, or being able to create that as a student, buildings for architecture students, whatever it may be. That's somebody's face actually that's been pretty well recreated. And these are my references. But again, this technology is not very popular, but right now MCore is actually partnering with Staples. Staples has something called Experience Center, and they're actually allowing the public to come in, experience 3D printing technology through this company, and print their own color versions of different things, a little bit of art. So I think this is a way to reach out to the public again, and hopefully there's a lot more applications to be thought of in